Hello everyone, welcome back. So now today we'll be covering the contains duplicate problem, which is one of the easiest problem from the blind 75 list, which we will be covering part of this series of problems we will be solving. So now let's look at what is this contains duplicate. So given an integer array nums return true if any value appears at least twice in the array, and return false if every element is distinct. So basically, if you are being given this input array, if you see here, if you anything which is repeating itself, like here in case one is getting repeated twice. So if you see there is a repetitive of any element, basically if you have any duplicate, you have to return true. And if you find all the elements are distinct, like in this case, there's no repetition, so you return false. Uh, and there's another use case. There's a constraint here that your numbers dot length, the array which is being given, is less than, which is equal to 10 power 5, which is somewhere around less than a million, in between 1 to that. That's the length. And all the numbers can be negative or positive, so it can have both. So how can we do this? I'll just go over the brute force approach, obviously, which is having, if we have to do it the brute force way, one of the thing is you can quickly take an element and compare with each and every element next to it, basically loop inside a loop. You can do it, so that way you compare this one with 2, and one this with 3, and one this with and the last one, and as soon you found it, that's basically you found a duplicate. So that's kind of like a loop, first loop, and then you had an inner loop. You can do that. Obviously the time complexity for that would be n square, which is not ideal in this case. So what improvement can we do it? There's another approach is that, so you can do it through sorting. Sorting is another approach. That's where you first sort the elements in a list, and then you compare the adjacent elements. You compare your I element with the I plus 1th element. So what happens when you sort this? You will get it like 1 2 1 1 2 3, and you compare uh, the adjacent elements. In that case, as soon you found any two adjacent elements are same, that's when you return a duplicate. If not, you just go over the whole array and you return false if there is no adjacent elements are similar. So that is another approach. Even though in that the time complexity is at least n log n, since you are sorting the array and then you're comparing it. So uh, just to sort it will be n log n, and iteration is log just n. So that is also something we are not looking in this problem. We want to do this, solve this one in a O of n time complexity. So how can we do that? So one of the approaches, we can do this through a hash map. Now what's a hash map? Here is you have this list wherein you have this you start to maintain a map of whatever the elements you have. So let's say you start to build a map, and as you start to enter the elements in the map. In this one, you have, as you iterate over, so you found a 1, so you make an entry of 1 in this one, and you set whatever value to it. You can just make it true, or you just put a count of it, so you got it as a 1. This is for example. Now again you got it 2. You will be checking that element exists in the map. That will be is 2 there in this map? No. Then you add this element, insert 2. The count of 2 is 1 at this point. So every time you'll take an element and you will be looking in that, and that lookup will cost you O of 1, because lookup of a map is O of 1. uh, so you will add that element. If you don't find it, you will just insert it. You will do this pattern until if you found that element already exists. So let's say in this case here, then once you enter this encounter the second one, which is the last element, you will make a lookup here and check, is this one already exist? The map will return true, which will say that there is already a key uh, is there in this map, and which will return me a true. And as soon you found there is already an entry, then that's where you will return that uh, true to the result. And if you go on through the whole array and if you don't find the map, if you don't find a repetitive element, basically none of the lookup returns you true, then in that case you return the result of this program as false. So that's the logic, and the time complexity will be O of n for this one, because you are just iterating over this whole uh, array only once, and you are just making the lookup into the map. So once you iterate over once, that's O of n, and then every time you're just making a lookup, so that means it's just O of 1, which is eventually O of n. So that's the time complexity of it. So let's code this solution. So as I said, let's define a map of nums. So I'll call it as map of nums. It's an empty map. So as the first thing is, we'll be iterating over the elements in the nums. So I in nums. So the first thing, every element we take, we will be checking that element exists in the map. So if I is in this map nums, so that means that that element already exists, and then as soon you found that element, basically that means that there is a duplicate, and you return it true. And if it does not, then the thing what you do is you insert that element in the map. So that will be maps of num of I, which will be equal to we can say just any value at this point. I can just say 1, or I can just put a counter, anything. So that's it. And if it goes through the whole array, and if it then still then find any of the element which is already existing, then you can return a false at the end. So that's about it. So let's run this. I got a quick error. Oh, okay, true is a spelling mistake. True. Sorry. Yep, that it has accepted the solution. Let's submit, and it has been accepted as well. So I hope you guys this clarifies this problem. See you in the next one. Thank you.